No? Yes, we're recording.
No.
So this is 11-2. So we've already seen arithmetic sequences, okay? And we're going to be finding, Quinn, stop talking, please, okay? So say we have this sequence, 2, 5, 8, 2, 5, 8, 11, 14, what comes next? 13, that's wrong. Okay, 17. So this is an arithmetic sequence. Who can tell me what's special about this arithmetic sequence? What's special about it? What makes it? It's going up by 3. So an arithmetic sequence is just that. It's one that's going up by the same amount each time, okay? And yesterday, that's an 11, by the way. That funny, I better fix that for our viewers in the studio audience, okay? That's an 11. So it's changing. So an arithmetic sequence is a sequence that changes by the same amount each time, okay? And this amount here, so arithmetic sequence changing by the same amount, and that amount, this number right here, 3, that they call, let's get rid of this, that they call the common difference. David, put your phone away, okay? This is called the common difference, and we abbreviate this with the letter D, okay? So we know that our common difference here is 3. Then we have the first term. The first term, first, not fist, first term, okay, is this one in this case, and that's called A sub 1, okay? So A sub 1 is the first term. First, does that look like first? That looks like a mess. Let's try that again, okay? A sub 1 is called the first term, and D is called the common difference. It so happens that we could write any arithmetic sequence in this form. Okay, A sub n, to find any term, the nth term, A sub n is equal to A sub 1 plus n minus 1 times D. So this is a very good formula to know, and this is kind of what we were leading into yesterday, okay? But it's an easy way to find the nth term. For instance, look at this sequence. Say I wanted to find A sub 5, right? The 5th term, right? I start with the first term, which is 2, plus n minus 1. What goes in for n? 5 goes in there, so you have 5 minus 1 times D, which I now know is 3. And I get that the 5th term is 2 plus 4 times 3, which is, what's that equal to? 14. And there we go. Here's the 1, 2, 3, 4. And just like I said, the 5th term is 14. Isn't that easy? Okay? So all you really need to know is the first term and the common difference. Sometimes finding the first term can be a little tricky, but it's not too bad. Okay? So oh, there goes my voice again. And this n minus 1 times D comes from the fact that I'm adding 3. I start with this term. I'm adding 3, 1, 2, 3, 4 times to get the next term. See it? Okay, so if I'm at the 5th term, I'm adding 3 4 times, that's where that comes from, to the first term. Okay? So here's one. Find the 12th term. What if I said find the 12th term without listing out all the terms? The 12th term of this sequence. 4, 7, 10, 13. 4, 7, 10, 13. What's D? What is D? D is 3. What's A sub 1? 4, right? So now I just plug into this formula. This is a formula you really got to know right here. Let's put a box around it. Let's make a red box. Okay? There's a formula you got to know. Okay? So you have the formula A sub n is equal to A, in this case, A sub 1 is 4 times 12 minus 1 times what? What? Times 3, right? So the 12th term, A sub 12, in this case, is just going to be 4 plus 11 times 3, which is, what's that, 37? 37. There you go. Got it? Easy enough? Easy enough. But sometimes the sequences get a little trickier, like they could go backwards. So say I have this sequence that starts, let's not go in, let's start with 100. And let's go to 96. And let's go to 92. And let's go to 88. Find the 30th term. Find the 30th term. Could you do that? You want to try it? What's D?
88. Oh, wait.
What's D?
Hold on.
It's not, it's negative 4,
Yeah.
right? Because it's going down by 4. So in this case, D is negative. So in this case, D is equal to negative 4. What's A sub 1? What's A sub 1? First term. 100, right? So you just go A, here's the general formula. A sub n is equal to 100
Yeah.
plus n minus 1. N minus 1 times negative 4, or you can make it minus 4 times n minus 1. And so if I want the 30th term, A sub 30 is going to be equal to 100 plus 30 minus 1, which is what? 30 minus 1, hello? 28. No, it's 29 times negative 4. Which is, how much does that make? 58? Negative 116? Right?
Yeah.
Yeah, negative 116. So you could have a sequence where you can have a sequence where it goes into negative numbers, okay? Nothing against that. Okay? Quinn. You're what? You look like you were talking. What were you doing? Okay. All right. So there's how you do that's that kind of thing. So then sometimes they throw tricks at you. Okay? Isn't this easy? Is this easy so far? So what if they say the third term, so the third term of a sequence is 24. The eighth term is 49. Find the formula or the rule, whatever you want to write. Formula, the rule for the nth term. Okay. Any ideas how to do this?
No, never mind.
Calvin!
I have, what?
Maybe.
Oh, you're not Calvin? Go ahead. No, go ahead, Jessica.
Would you subtract 24 from 49 and then like divide by 5?
Exactly.
How do you even get that?
Okay, so, because she said, okay, so here's the terms, right? First, second, third term, right? So this would be the third term, right? Fourth, fifth, sixth, seventh, eighth term. Yes? This is kind of what she was thinking, right? And she knows that this term is 24, and she knows that this term is 49. How many times do I do the common difference between those two terms? 5, right? Once, twice, threes, 4, 5. So if I subtract 8 from 3, that means that I've added that common difference 5 times. Get it? That's what she's, thinking. And she said that total difference, right? The difference, 49 minus 24, is what? Is 25. And then I divide that by 5. And so D, so this is equal to D, which is equal to 5. Now I got to find the first term. How can I find the first term? Subtract. That's right, David. How do you know that?
Because there's two species.
Right, because this would be the second term. First term would be over here. So I subtract that common difference twice, right? So subtract 5 again. So the first term would have to be 14. Okay? And now, well, my Moby board story. So now I could write the formula for the nth term, which is the first term, which is 14 plus n minus 1 times 5. There you go. Not impossible. That's not that hard, is it? In my pre-calc and algebra 2 classes, I don't teach algebra. In pre-calc we do this, but we set up 2 equations and 2 unknowns. At this point, we're just doing it like that. Okay? But some of my students do it this way, which is kind of the cheater way, but it works. Okay? We're not, yes, sir?
I'm really confused how you got the 14.
How did I get the 14? Okay, so I know that D is 5. Do you understand how I got D is 5? So if I subtract 5, I get this term, right? Subtract another 5, I get this term. Subtract this 5, I get this term, 5, right? So I need to know the first term because that's the thing. This is a sub 1, right? And I need to know that in the formula. And so if I subtract 5 twice, right, I get 14. That's for the 14. Here, we're going to try one, okay? So you try. Whoever gets this other than Jessica gets a Tootsie Pop, okay? You try. You try. Jessica already give you a Tootsie Pop because you got that one right. Fourth term. The fourth term is 5. And the 21st term, is 175. Find the formula. And go ahead, give that a shot. I gotta pause. So she did 175 minus 5 is 170. And then what do you do?
I subtracted 161.
Right. She knew that there's a fourth term and the 21st term, so 21 minus 4 is 17, which gives, right? And then you divide it, right? So this gives you D, right? Which is equal to 10. And then how do you find a sub 1?
Well, I knew that I had, from 1 to 4 it was 3 times.
Right. Okay.
So I just multiplied the 10 by 3 to 30.
So she started with 5, right? And then she took away 3 times 10, right? Because it's going away. So that makes negative 25. And then you could write the formula a sub n is equal to negative 25 plus n minus 1 times the common difference, which is 10. Good.
Did you
Okay?
do the other one different? Because you divided the other one by 5 and then this one by 16. Or 17.
That's because the other two terms were only, if we go back, right? These ones were only 5 apart, so from 3 to 8, there's only 5 terms, right?
Yeah.
In this problem that I did from,
I forgot. I
right,
had another comment.
from 5 to 20, from 4 to 21, there's
I forgot
17
comment.
terms. Yeah? Okay, so this is a really cool formula that I'm going to teach you.
Spaces.
So there's this guy, I forget who it was. Maybe it was Descartes. It was some mathematician when he was in high school. And his professor said, add all the numbers, find, I think it was Rene Descartes, okay? Find the sum of the numbers from 1 to 100. And all the students were working furiously away, and Rene Descartes, I think it was Descartes, I'm not sure, don't quote me on that. But he raised his hand, and in like 2 seconds, he goes, I got the answer. And he was like, oh, you do that.
From this.
So, but there's a trick. Anyone think of a trick I could use to figure out the sum of the numbers from 1 to 100? What if I added 1 plus 100? How much do I get? What if I added 2 plus 99? What if I added 3 plus, what did I add next? 98. What does that make? 101, 101, 101. And I'd go that way. How many times if I were adding all the numbers from 1 to 100? Not 100, 50. I'd take half of it, right? So that's basically what Rene Descartes did. He said, well, if I take the first term and the last term, right, and I add them together, and then I multiply by how many terms there are, okay, which was 100, and I divide by 2, because I'm not doing it for every number, I'm doing it for every other number, then I would get the sum of the first 100 numbers, okay? So this would be 100 divided by 2 times 101, which I think makes 5,050. So if you added all the numbers from 1 to 100, you would get 5,050. Okay? So turns out you could do that with any arithmetic sequence. So if you started with like 3, and then went to 7, and then went to 10, and then went to 13, and you did that all the way until you got to, 300, and you wanted to know the sum of all those numbers, all you have to do is add this number plus this number, figure out how many terms there are, and then divide by 2. Multiply by how many terms there are, and divide by 2. So here's the formula, okay? The sum of an arithmetic sequence, S sub n, okay, which stands for the sum of an arithmetic sequence is S sub n, okay, S sub n, which means the sum is equal to, let me make sure I write this down, n over 2 times a sub 1 plus a sub n. So this is how many terms there are. This is the first term, and this is the last term. Okay? So say I asked you to find the sum. Find the sum. Okay. 200. Okay? Any ideas? How many terms would there be? Are there 100 terms or is there less than 100 terms?
Well, if you put in 0.
First term, second term, third term, fourth term, 100 terms, right? So this is n equals 100. The other way you could do this is you could say, well, I know that this sequence, a sub n, is equal to a sub 1 plus n minus 1 times d. What's d in this case? 2, right? Watch this. This is important to know, too, okay? So sometimes you don't know what term this is, and you have to figure it out. So if you look at the beginning of the sequence, I can figure out this number is 2, right? This number is 4. So a sub 1 is 2. It's going up by 2's, right? So to figure out what term, this is an easy one just to do by looking at it, but it's not always that easy. So before I could use this formula, I need to know what n is. So I need to know how many terms I'm adding up, right? So what I do is I put 200 over here, because this is the 200, the term that is 200 is 2 plus n minus 1 times 2. And if I solve this for n, the first thing I would do would be subtract 2 from both sides, subtract 2, and I get 198 equals n minus 1 times 2. Then what do? How do I get rid of this 2? Divide both sides by 2, which gives you n minus 1 equals 99. And then I would add 1 to both sides, right? So then I get n equals 100. So this is the 100th term. But this one's easy to tell just by looking, but a lot of times you have to figure out what term do I end up, okay? So now I can use this formula to figure out how much that all adds up to. So the sum of the first 100 terms, in this case, S sub 100, is equal to 100 terms divided by 2 times the first term, which is 2, plus the last term, which is 200. Good? And it's easy to simplify this, so I get S sub 100 equals 50 times 202, is that right? 50 times 202. Anyone do that in their head? 5 times 2 is 10.
1,100.
1,100. So, is it 1,100?
10,000.
10,000. It's 10,100. Very good. Good? Do you understand that? So you take the first term, the last term, you multiply by how many terms there are, and then you divide them up. Divide them by 2, and that'll give you the sum of the first 100 terms. So here you go. Your turn to try. Okay? Ready? Find the sum. Oh, there we go. I know it's a lot of math. This is good math, though. This is fun. This is fun math. Okay? Find the sum of the first how many terms? 15 terms. 15 terms without cheating, without like adding up the first 15 terms. For 13 plus 10 plus 7 plus 4 plus dot, dot, dot. Okay? Where you're finding the sum of the first 13 terms. I got to do that. Okay? So, So D we said was negative 3, and a sub 1 is what?
Mr. Mindy,
Yes?
I got it right.
I know, but so did Mindy. You got it right from the last time. You can't get another, or you got one last time. Spread the wealth. Okay, what's a sub 1? 13, right? So I know that a sub 15, right, is going to be 13 plus n minus 1 times 15, right? Which, so the 15th term is going to be 13 plus 15, no, that's wrong. That should be negative 3 right there, right? Negative 3, okay? Negative 3, 15 minus 1 times negative 3, and that gives you 14 times negative 3, negative 42. This gives you negative 29, right? So a sub 15 is negative 29. Then to find the sum of the first 15 terms, I take the first term, which is 13, the last term, which is negative 29. I multiply by how many terms there are, which is 15, and I divide that answer by 2. Okay? So this makes negative 16, right? Negative 16 times 15 divided by 2, and I would divide by 2 first and then multiply by 8, which gives you negative 120. Not that horrible, is it? They're kind of fun, okay? I think. All right, so that's kind of it. That's it. You have Math Excel homework to do, okay? And it's on my school sheet, and I like this stuff.